So now that we have discussed basic theory about eigenvalues, eigenvectors, so let's solve some problems, previous gate questions on eigenvalues and eigenvectors. So let's take branch by branch. So we'll solve about 5 to 6 questions from previous years, combining all the branches. Okay. Previous gate questions. Okay. So let's take the EC 2009 question. So let me write down the question first and then we'll see how to solve it. So what was asked was the eigenvalues of the following matrix. Matrix are, so let me first give you the matrix first and then I'll write down the options and then we will solve it. So this is quite a cheeky problem. You'll just find out. So option A is this, option B is minus 6 plus 5j comma 3 plus j minus 3 minus j. C bit is 3 plus j, 3 minus j, 5 plus j. D bit is 3 minus 1 plus 3j comma minus 1 minus 3j. Okay, so this is the thing. So now how do we find out the eigenvalues? The basic starting point is writing out the characteristic equation which we have seen. So characteristic equation is nothing but det of, if you assume the matrix to be A, okay, so it's det of A minus lambda I is 0. So let me just write down this. So it's basically diagonal terms subtracted with lambda, and then the remaining terms are all same. Okay, and this det is 0. So now this will give it to, now how do we determine det here? Because let's use the last row because these two are 0, so it will be basically 3 minus lambda this thing into AD minus BC. So minus 1 minus lambda into minus 1 minus lambda minus 3 into minus 3 is equal to 0. So we'll get 3 minus lambda, we'll get lambda plus 1 whole square minus or plus 9 is equal to 0. So this means, let me just expand, so this I can write lambda minus 3, or let's not do anything here silly here. So 3 minus lambda, and this will be lambda square plus 2 lambda plus 1, that plus 1 combines with 9 becomes 10 is equal to 0. So this means 3 minus lambda is equal to 0, or lambda plus 2 lambda plus 10 is equal to 0. Okay, so lambda is equal to 3 here, and here lambda is equal to, let's use the quadratic formula. So minus 2 plus or minus b square, which is 4, minus 4 into 10 AC, which is A is 1, C is 10 by 2. So plus or minus and this root. Okay, so this will give me minus 2 plus or minus 36 by 2, and this will be basically minus 2 plus or minus, this will be 6 root minus 1 by 2, which is again minus 2 plus or minus 6i by 2. So complex variable, sometimes it is written I, sometimes it is in j. So let's, because options are in j, so let's write j as root minus 1, and this is minus 1 plus or minus 3j. So now the roots are basically this, and then you have the complex root. So it's basically 3 minus 1 plus 3j minus 1 minus 3j. So the options option. Looking at the option, the answer is D. So 3 eigenvalues for 3 by 3 matrix, and this is the standard procedure for finding out eigenvalues. So 2009 EC problem was quite an easy problem. So let's discuss now the EC 2005 problem. Given the matrix -4, 4, 2, 3, the eigenvector is 3, 2, B bit 4, 3, C bit 2 minus 1, D bit minus 2, 1. Okay, so now one thing we can always, whenever the options are given an eigenvector results, you can always check Ax is equal to lambda x, but then you don't know lambda. So let's first find out the eigenvalues and just do it in a standard way. Okay, so what we'll do is we'll first finding out the eigenvalues. For that, because A is this, so I'll just subtract with lambda on the diagonal terms and then take the det of this matrix. Basically, so it's basically det of -4 minus lambda 2, 4, 3 minus lambda is equal to 0, and that is nothing but AD minus BC for a 2 by 2 matrix. So it is -4 minus lambda into 3 minus lambda minus 2, 4 is equal to 0. So this comes out to be 4 plus lambda, I mean let's just multiply, -12 plus 4 lambda minus 3 lambda plus lambda square minus 8 is equal to 0. So this comes out to be lambda square plus lambda minus 20 is equal to 0. So this if I factorize this, I can write 5 lambda minus 4 lambda, because 5 into minus 4 is 20. So this will give me I can take lambda common, so lambda plus 5, and there I can take minus 4 common, so lambda plus 5 is equal to 0. So this will give lambda minus 4 into lambda plus 5 is equal to 0. So the roots are 4 and minus 5. Now so there will be two eigenvalues. So let's see, corresponding to lambda is equal to 4, what is my eigenvector? So lambda is equal to 4. So eigenvector, again I have to use this form. Okay, or I can always write A minus lambda I into capital X is 0. So just using that equation, -4 minus lambda, lambda is 4 here, lambda is 4 here, then 2, 4, 3, lambda is 4 here, so 3 minus 4 into your h1 h2 equal to that's is equal to 0, 0. Okay, so now this will be basically your 0, 2, 4 minus 1 h1 h2 0, 0. So this will give rise to 2h2 is equal to 0 and 4h1 minus h2 is equal to 0. Okay, so what does this mean? So this means that h2 is h1 h2 are all zeros. Okay, so first, so 0 comma 0 is one eigenvector, but that's not in the option. So let's try for other lambda is equal to 5. So for lambda is equal to 5 minus 5, sorry, lambda is equal to minus 5, the equation is -4 minus 5 2 4 3 minus 5. So minus of minus 5, it will become plus 5 here and plus 5 here, because lambda is itself is -1, and then h1 h2 0 0. So this will give rise to x1 plus 1, so x1 plus 2x2 is equal to 0. 4x1 plus 2x2 is equal to 4x1 plus 8x2 is equal to 0. So I mean, you can see that first and the second equations are basically equal. This, when you divide the second equation by 4, so you have basically effectively you have x1 plus 2x2 is equal to 0. This is the one equation. So now if I assume, so now I can actually see which of my options satisfy this. So I can just see that option C is 2 minus 1 will satisfy this. Okay, 2 minus 1 and minus 2 1, so both C and D will satisfy this. So here actually both both C and D would satisfy this, because you can I think this might be some add score problem there, because both C and D, if you substitute here, will satisfy this. And even you know that if x is a eigenvector, then multiplying x, because like the difference between option C and D, the C option was 2 minus 1 and the other option is minus 2 1. So you just subtract minus 1 to the first column vector, you will get the second column vector. So that is like multiplying an eigenvector with a constant. The constant times the eigenvector is also an eigenvector. Okay, so I think both C and D, in principle both C and D is the answer, but then you have only one choice. So I think this should have been an add score problem. But another way, so this is one way which we have done, which is the more standard way. Other way is all directly from the options. You can always check that Ax you can compute always, and that if that becomes some constant times x, then x is basically an eigenvector. Right, so basically directly from the option you can come, and you will find out that if you take this matrix minus 4, 2, 4, 3, and if you take A option or B option or C option, so let's try with C. So this will come out to be just multiplying, operating that vector onto the matrix. So then what you will get, minus, just multiplication, so minus 4 into 2 plus 2 into minus 1, 4 into 2 plus 3 into minus 1. So this will give rise to minus 8 minus 10, so minus 10, 4 2 is 8, minus 3, so 5. And now if I take minus 5 comma, okay, if I take 5 comma minus 5 comma, if you want to take, so this will be basically 2 comma minus 1. Okay, so if you take minus 5 comma, it will be 2 comma minus 1. So from this you are just again got back the same equation, right? Got back the same 8. So this I can write lambda times x, right? Or had it been, if you start with the option D also, what A and B will not satisfy this, you can just check it. Okay, so had it been, if you start with minus 2 comma 1, then this would give rise to be plus 8 plus 2 minus 8 plus 3. So this would be your 10 minus 5, and then if you remove minus 5 common, you will get 2 minus 1, or if you remove 5 common plus 5 common, it will be 2. I think you have to remove minus 5 common, so then it will be minus 2 and 1. So you again get back the same vector. So this is again lambda times x. So these kind of problems, so again again C and D, both options C and D options satisfy, option C and D. Okay, so the basic idea here is that whenever these kind of, here it might be an add score problem, both C and D satisfies, but learn the concept. The basic idea is, given eigenvector, you can always operate it on a matrix, and if you are getting some constant times that eigenvector, I mean, if you are multiplying, like here we took 2 minus 1, we just multiplied with the given matrix, and we got some constant into the same vector with which we multiplied. So then it becomes an eigenvector. So even that was happening for D also, option D also. So always whenever you are given a matrix, you are asked to find out eigenvector. One standard procedure is get the eigenvalues, and then routine procedure, get the eigenvalues first from the characteristic equation, and once you get the eigenvalues from the characteristic equation, you have to just again get back to the equation a minus lambda I into x is equal to 0, and from there you will get the general form of the eigenvector. Okay, that is somewhat lengthy. The other way is directly from the options, just use one of the option because there are only 4 options, so use each option, multiply with the matrix Ax. That should be something of the form constant. Once you multiply, it should come out of the form, it should come out in such a way that Ax should be some constant into x, or that constant is basically your eigenvalue lambda into x. So you should multiply a matrix with the vector such that you get back some constant times the same vector. Okay, so and obviously only one of the options will satisfy, and that option will be your eigenvector. So we discussed this simple problem in a very detailed way, so you can choose any of the method. I would suggest you should choose the second method which I told you. Take each option, multiply with the matrix. If you are getting the same, so take a vector, multiply with the matrix, and if you are getting the same vector, some constant time multiplication of the same vector, then that becomes your eigenvector. So multiplication is quite easy. You can just check all the 4 options and you can easily find out eigenvector. Or you can, if you want, you can just choose the routine method, finding out the eigenvalues and then go into the eigenvectors. Okay, so let's try another gate problem, previous years, EC 2006 this time. So let me write down the question. For the matrix 4 2 2 4, the eigenvalue corresponding to eigenvector 101 is A bit 2, B bit 4, C bit 6, D bit 8. Okay, so I would suggest, because the starting equation is always Ax is equal to lambda x, so if you operate any vector x on A, and if you are getting some constant times that vector, then that vector is called eigenvector, and this is called your eigenvalue. Lambda is called eigenvalue, x is called eigenvector. Okay, so I would suggest take a matrix, and anyhow eigenvector is given, so just operate it. So let's take 4 2 2 4. So basically we are taking Ax. Okay, and eigenvector I am taking 101 101. So if I multiply, I would get 4 into 101 plus 2 into 101, then 2 into 101 plus 4 into 101. So this I'll be getting 404 plus 202, 202 plus 404. So this will give me 606, and I can take out common sets, you can see, and I'll get again the same vector 101 101. So this 6 is your eigenvalue, because I am getting in this form. Started with this, I got this, so Ax is equal to lambda x, and this lambda becomes your eigenvalue. So it is this 6. So 6 is the answer. Option is C. Answer is C. So let's see another problem. Triple 2009. Okay, so this is quite a cheeky problem again. The trace and the determinant for 2 by 2 matrix are -2 and -35 respectively. So its eigenvalues are A bit -30 and -5, B bit -37 and -1, C bit -7 and 5, D bit 17.5 and -2. So this is, we know that during the properties of eigenvalues we studied that if it's a 2 by 2 matrix, so it will have two eigenvalues. So let them be lambda 1 and lambda 2. Now sum of the eigenvalues is basically sum of the diagonal terms, and that is called as trace, which is -2. The product of the eigenvalues is the determinant. So these are two important properties. Satisfying these two, you can see that, and orally just see that, because you can just solve it also, but you can see that lambda 1 is equal to 5 and lambda 1 is equal to 7. You can solve, but I think we can just directly guess the values. So if lambda 1, if I assume -7 and lambda 2 as 5, so the plus, if you add these two, obviously -7 is bigger, so you will get -2. If you multiply, obviously -7 into 5, it will be -7. So based on just looking at that, you can guess that is -7 and 5. These are the answers, and therefore C is the option. So now let's see the triple E only, triple E 2007 link data question. Okay, so the Cayley-Hamilton theorem. So let me read out the question. The Cayley-Hamilton states that a square matrix satisfies. So that's already given actually. The statement of the Cayley-Hamilton theorem is given in the question. So states that a square matrix satisfies its own characteristic equation. So that is in fact this is given actually in the question. So even if you don't know Cayley-Hamilton theorem, you can still end up solving this problem. So consider a matrix A is equal to -3, 2, -1, 0. So now let's okay. So this is the question. So this is a linked data question. The first question was A satisfies the relation, and options are given. Let me write down the option. A is A plus 3i plus 2a inverse is equal to 0. Option B is A square plus 2a plus 2i is equal to 0. C bit A plus I into A minus 2i is equal to 0. D bit exponential of A is equal to 0. So this was first question, because it's a linked data question. So the second bit being A power 9 equals, as I told you in the question, while I was teaching Cayley-Hamilton, that higher powers is easily calculated by Cayley-Hamilton theorem. So let's do this problem. B bit is 309a plus 104i. C bit is 154a plus 155i, and d bit is exponential of 9a is equal to 9a, yeah, exponential of 9a. So now I need to find out. So now let's first find out the characteristic equation of the matrix, which is nothing but minus 3 minus lambda 2 minus 1 0 minus lambda, and that is 0. So this will give minus 3 minus lambda into minus lambda. So this is just like AD minus BC is equal to 0. Okay, a matrix A B C D, determinant is 0 means AD minus BC is equal to 0. So this is minus 2 minus 1 into 2 is equal to 0. So this will come out to be 3 plus lambda into lambda minus plus 2 is equal to 0. So this means lambda square plus 3 lambda plus 2 is equal to 0. So this means lambda. Okay, so this is your characteristic equation. Okay, so here actually I have written a square plus 2a, but it's actually a square plus 0. So let me write it clearly. A square plus 3a plus 2i is equal to 0. Okay, so this is the characteristic equation, and as Cayley-Hamilton theorem says that you have to just replace lambda with a. So basically your matrix satisfies the Cayley-Hamilton theorem. So that's like a square plus 3a plus 2i is equal to 0 in matrix form. So this is the answer for a bit for first question. So the option is B, sorry, and answer is that a square plus 3a plus 2i is equal to 0, or the null matrix. Okay, so for first question the answer is A. Answer is B, sorry, option is B. Answer is a square plus 3a plus 2i is equal to 0. Now let's evaluate a power 9. Now how do I evaluate a power 9? So let's start from a square. Now a square I know it's minus 3a minus 2i. So now let's compute a power 4. So a power 4 I can write a square into a square. So let's evaluate a power 4. So a square into a square. A square we already have from the Cayley-Hamilton theorem. So that is minus 3a minus 2i into minus 3a minus 2i. So this means basically if you just expand each and every term, 9a square plus 12a plus 4i. Okay, and now a square again I can just write, because everything has to be in terms of a square, all the a square terms I can always write a square as minus 3a minus 2i. So plus 12a plus 4i, and that becomes, if I simplify, it becomes minus 15a minus 14i. Okay, when you simplify. So this is just only a power 4. So similarly if you evaluate a power 8, because a power 8 is again, so we can, instead of evaluating a power 6 again, we can evaluate a power 8 directly, because a power 8 will be a power 4 into a power 4, which is basically, already we got a power 4 in terms of a and I. So I can just use this minus 15a minus 14i minus 15a minus 14i. So this will become, so this will basically become 220, this will become 225 a square if I simplify, plus 420a plus 156, 14 square 156i. So now again I can take 225 square common, 225 common. A square is again minus 3a minus 2i, and the remaining is all same, 420a plus 156a. So the basic idea is getting everything in terms of a and I. So this means if I simplify, it will be minus 225a, because 225 into 3 will make you 675 plus 420, so it will be minus 225 minus 254i. Okay, so this is just a power 8. So now what I have to do is a power 9 I want. So this is just matrix multiplication. So a power 8 into a and a power 8 is minus 225a minus 254i into a. Okay, and so this will give minus 225a square minus 254a, and a square I can always write minus 3a minus 2i from the Cayley-Hamilton theorem. Okay, and this will give me, if I simplify, 511a plus 510i. As you can see, 225 into 3 675 minus 675 plus 675 minus 254 will be 511 and plus 510. So the answer is 511a plus 510a for a power 9, and the option is A. So now let's see mechanical ME 2006 problem. Okay, so the eigenvalues of a matrix S is 2 3 2 2 3 are 5 and 1. So it's already given, eigenvalues are given. So what are the eigenvalues of S square? So that is what I mean. Even the matrix itself is given. I mean, you if only, so we are supposed to find out S square eigenvalues, and S eigenvalues are given. Even if eigenvalues are not given, matrix is given, you can easily find out. So option A is 1 and 25, option B is 6 and 4, option C is 5 and 1, option D is 2 and 10. So if you recall whatever we studied in properties, that if you have a matrix A and its eigenvalues are lambda, for matrix M the eigenvalues will be lambda power m. So similarly, because its S has eigenvalues 5 comma 1, so for S square it will be 5 square comma 1 square plus 25 comma 1. So the answer is 1 and 25, option is A. But if you don't know this, say, I mean this simple fact, if you don't know this simple fact that for a square matrix A, if the eigenvalue is lambda, then for any power matrix, that is A power m, the eigenvalues are also basically to the power m. So if you don't know that fact, I think for this problem you need not know. You can just start with S square, which is S into S, and you can just multiply 3 2 2 3 3 2 2 3, and this would give you, let's multiply 3 3 is 9 plus 2 2 is 4, then 3 2 6 plus 2 3 6, 3 2 6 plus 3 2 6, and then 2 2 is 4 plus 3 3 is 9. So this will give you 13 12 12 13, and now we need to find out of the eigen values for this. So this is 13 minus lambda, 12 only, then 12, then 13 minus lambda is equal to, okay, I mean the depth of this has to be 0. So implies 13 minus lambda whole square, because 13 minus lambda into 13 minus lambda minus 12 whole square is equal to 0, which means 13, if you just expand, this is 169 13 square plus lambda square minus 26 lambda minus 144 is equal to 0. So this would mean lambda square minus 26 plus 25 is equal to 0. So this means lambda square minus 25 lambda minus lambda plus 25, because minus 25 into minus 1 will give you 25. So now factorizing it will give you lambda minus 25 lambda minus 1 is equal to 0, implies the values are lambda 1 and 25. So this will involve some process if you don't know this very fact. So if you know the fact, it's well and good, that A power m, anything, if you know A, and if you know the square matrix A, and if you know its eigenvalues, then anything to the power of A, that is a to the power of 2 or a to the power of 3 or 8 higher powers of a, you can always find out the eigenvalues of higher powers of a once you know the eigenvalues of a. If you don't know this fact, well, then you have to just multiply, and so we have done both the ways. If you don't know the fact, you just multiply and finding out the eigenvalues in the standard procedure. So the answer is A. Option is A. Answer is 1 and 25. So the answer is A. So I mean, most of the eigenvalue problems are like this. In almost, we have solved some problems mostly in EC and Triple, and one more problem in ME. So most of the problems are like this. So just knowing what is eigenvalues and eigenvectors and just couple of properties, I think that would be sufficient for, because look at most of the previous questions are just similar to this.